let's look at another application of the sum formula for cosine. So in this example, we actually have a few problems in one. We're told what the value of sine of x is. We're told it's 4/5, and we're told that x is in quadrant 2. Now that is enough information to determine what x is. Similarly, for y, we're told the cosine of y is 5/13 and that y is in quadrant 4. And again, that's enough information to determine what y is. And from that, we're supposed to figure out what cosine of x plus y is. Now remember, to get cosine of x plus y, we need to know both the cosine of x and the cosine of y and the sine of x and the sine of y. Those are all ingredients in the formula. But all we've been told is sine of x and cosine of y. But remember, we can figure out the other information. So let's just do a quick little drawing of what x must look like. So we're told that x is in quadrant 2 and that sine of x is 4/5. So if you remember our knowledge about how the sine of an angle is defined in terms of a point on the terminal ray of that angle, we can draw x to look like this, where the leg here is 4 and the hypotenuse is 5. So in other words, this point, once we do a little bit of Pythagorean theorem, we'll see that this other leg here is -3. So we have a 3, 4, 5 triangle. So that the coordinate here then is -3, 4. So that is angle x. X is the angle which goes through the point -3, 4. And now similarly, we can draw what y has to look like. So we're told that y is in quadrant 4, so y will be down here, and the cosine of y is 5/13. So let's think about what that means. Well, it means that the positive, well, cosine is positive there. We have a leg here which is 5, and hypotenuse which is 13. Right, because cosine is adjacent over hypotenuse. And so y, we can think of y as being this angle here. Comes all the way around to this, and this is our little right triangle that represents what y is. And now again, we can do a little bit of Pythagorean theorem and find that this leg here is going to be length 12, but since it's in the fourth quadrant, it's actually going to be -12. We can think of that as a negative length. And now with all this information, we can read whatever we need to know about either x or y based on the definition of the sine and the cosine of x and y in terms of a point that the terminal side of the angle goes through. So here's the point 5, -12. We figured that out. Okay, so now that we have those pieces of information, we can now apply our formula for the sum of angles with cosine. So what is cosine of x plus y? Well, remember it's cosine of the first angle times cosine of the second angle minus sine of the first angle times sine of the second angle. And now, well, some of this information we were already given, but the rest of the information we can read off of our reference triangles, our drawings that we did over here. So cosine of x, we weren't told cosine of x, but if we look and consult our little reference triangle here, we know that x, the cosine of x, is adjacent over hypotenuse. It's -3 over 5. So cosine of x is minus 3/5. Cosine of y, we were told it's 5/13. And now sine of x, we were told was 4/5. And sine of y, we were not told, but we can consult our reference triangle over here. And remember that sine of y, sine is opposite over hypotenuse, so negative 12 over 13 is sine of y. And now we have everything we need. We can simplify this. We're going to have a common denominator of 65. And in the numerator, we're going to have minus 15. Minus a minus, so plus 48 all over 65. And that becomes 33 over 65. So that's our answer for cosine of x plus y. Now let's do an example where we are told what the value of sine is for x and this value of sine is for y, along with the quadrants. And from that information, that's enough to determine the cosine of x and the cosine of y, which is what we need to compute cosine of x minus y. So let's quickly draw the angle x and the angle y and figure out a reference triangle for each of those. So for x, well, we know that x is in quadrant 3, so x is down here somewhere. And we know that sine of x is negative 5 over 13. Well, the negative comes from the fact that it's in the third quadrant, so it has a negative 5 here. And then it's over the hypotenuse. Remember, that's the definition for sine of an angle through a point. It's opposite over hypotenuse. So this angle is x. And we can figure out what that other leg is just by doing the Pythagorean theorem. So this leg here is going to be negative 12. This is a 5, 12, 13 right triangle. So that means this point here is minus 12, comma, minus 5. That's the point there. Okay, so that's x. Let's think about what y is. So y is in quadrant 1, so we don't need to draw too big of an axis. And sine of y is 3/5. So 3/5, that should look something like this. So we have a 3 on the opposite and a 5 on the hypotenuse. And you probably know the 3, 4, 5 right triangle, so this leg is 4. And so we have this angle in here, that is y. So now that we have x and y, and let's label the point for y, that's going to be the point 4, 3. Now we have everything we need for the ingredients in the formula for cosine of x minus y. Remember, we needed cosine of x and cosine of y as well as sine of x and sine of y. But so now we have everything we need, or we'll be able to compute it when we need it. So let's just remind ourselves, so cosine of x minus y, that's going to be cosine of x times cosine of y, and then it'll be plus sine of x times sine of y. So again, that's just the formula for cosine of x minus y. And now we put the work that we did to work. We're going to see what is cosine of x. Well, cosine of x, according to the definition for cosine through a point, is adjacent over hypotenuse. It's negative 12 over 13. That's what cosine of x is. Now let's find out what cosine of y is. Cosine of y is, again, adjacent over hypotenuse, so 4/5. And now sine of x, well, sine is opposite over hypotenuse, and we also were told that it's -5/13. And sine of y, we were also told was 3/5, and that agrees with our diagram, right? Opposite over hypotenuse, 3/5. Now we just need to simplify. We have a common denominator of 65, and in the numerator we're going to have minus 48, and then a minus 15, all over 65, and that comes out to be -63 over 65. So that's our final answer for cosine of x minus y.